Okay, greetings, distinguished members of the IEEE CSCC conferences. We are Hayo Kim, Yeji Do, authors of the paper Designing a Cloud-Based MES Software as a Service Platform Model in Precision Machining. Today, I have the honor of presenting to you the topic of designing a cloud-based MES and SaaS platform model. Yes. Okay. This is our table of contents. Our works and the papers consists of 5 different sectors. First one is background and need for research. Second one is research summary. And third one is related research. And fourth one is research ideas. And last but not least, fifth one is discussions and challenges issues. We have worked on this paper because of the problem of the initial high cost and the lack of compatibility in the digital transformation era. The precision laser processing industry in Korea continues to expand and increasing from 641 in 2010 to 21,896 in 2019. The number of workers is declining absolutely, and the need for and interest in ICT and digital transformation is growing. But in the case of SMEs, like small and medium enterprises, there is a high burden of large costs and a relative lack of leisure to build and introduce software such as MES and ERP at the beginning. Not only domestically but also internationally, there is a lack of compatibility between manufacturers' solutions such as MES and ERP, expanding the need for a modularized system that utilize the industry-specific solutions. Okay, so for the problem solution of the background I have mentioned at the last page, the research summary is that the smart manufacturing landscape is growing rapidly at the home and abroad. As a result, SMEs are realizing the need for digital transformation. However, there are difficulties in implementing it, such as initial costs and lack of resources, as I mentioned at the last page. And in this research, we aim to design a cloud-based subscription MES platform for SMEs specializing in the precision machining industry to operate efficient production processes and improve productivity and competitiveness. This utilizes modularized systems that allows you to selectively leverage the features you need, and this can save your money and time on your initial investment. And the cloud-based subscription MES system builds on the data standard AAS to collect and store manufacturing interlocking data. We want to design an MES software as a service platform that SMEs can utilize to keep up with the growth of smart manufacturing environments. Okay, let's dig into the related research of our work. The manufacturing execution system, which can be shortened as MES, is a system that provides information to help production departments make decisions to optimize the production activities required to produce a product. MES controls process and facilities management through real-time data collection and monitoring of production sites and analyze accumulated production site data to make decisions related to production. The Ministry of Trade, which is located in South Korea, Industry and Energy defines the smart factories as a factory that maximizes the overall efficiency of production by customizing advanced manufacturing technologies such as information technology, software, and 3D printing into the production site. Okay, next one is cloud service platforms. As you, the audiences are, I know that all the audiences can acknowledge this solution and technology is really important and substantial in this era. Infrastructure as a service, IaaS, is an evolution of on-premises infrastructure offering virtualized servers, storage, and networks. Users of IaaS services only need to pay for computing resources based on usage and time, which can significantly reduce the initial investment cost. Platform as a services (PaaS) provides developers with a foundations for building scalable applications unlike traditional systems. Software as a service (SaaS) is the most comprehensive form of cloud computing practices where the application software runs on the service provider servers. Users don't need to install or manage any software with these technologies and have instant access to the features they need through our web browsers. As you can see at the right hand side, there is an on-premise, an IaaS, PaaS, and SaaS structures in the figures. And next one is which can be really like skyrocketing the technologies in this industry. Uh, it is AAS and OPC UA and EDC. AAS is the Asset Administration Shell, which is called an administration shell or asset management shell. It provides and manages all assets, information, and technical functions in the real world of manufacturing through a digital twin server in the information world. And in its implementation, AAS envisions integrating automation ML, machine learning with Office UA technology to prototyping I industry for their components. OPC UA is the communication layer of the international standard IEC 620.541. It supports communication within a single machine, communication between multiple machines, and horizontal and vertical communication between systems. It supports the interoperability of data assets from various devices when building a smart factory. EDC is a Java-based open source software application supported by the Eclipse Foundation. It enables distributed systems to maintain the consistency and integrity of data assets that operate without a unified set of common rules. Okay, after screening out all the related works and the technologies related to our topic of research, we have some research ideas regarding the cloud-based cloud services. First one is system architecture. As you can see in the figure on the top, the automation ML asset administration shell standard was used to manage the information asset of the precision machine process. This standard provides the basis for digitizing process assets, integrating them into a SaaS platform, and collecting data. The Eclipse Data Space Connector standard data link socket is used to integrate and collect data. There is some flows at our figures. It is designed to compensate for the lack of data compatibility between different information assets and numerous manufacturers, making it easy to provide services under the MES-SaaS platform. In addition, by deploying AAS on assets in the manufacturing system, it is designed to enable Industry 4.0 components to operate autonomously, allowing them to operate independently without centralized control. Okay, and oops, it doesn't work. Sorry. Second one is hardware and software architecture. It consists of equipment such as UV laser cutting from precision machining, machine statistical analysis, and collaborative robots. PLCs and edge gateways operate in a client-server fashion. exchanging data between industrial devices and systems via OPC UA communications, and providing complementarity. Yes, and data collected from PLCs and existing facilities is stored in a dedicated MES databases throughout the MES systems. To collect this as AAS-based data, the existing data is converted to AAS standard datasets from the thorough AAS standard conversion software. The converted data is collected and stored in the AAS dataset databases in the cloud environment. The newly stored equipment collects AAS-based data to the edge gateway through OPC UA communication. The AAS standard dataset form is created based on the previously collected data. The completed AAS form is delivered to the AASX file of the cloud services and the OPC UA client, which is then sent to the OPC UA aggregation server of the edge gateway. During this process, the transmitted data is organized according to the AAS standard so that they can be interoperable with each other. Okay. Third one is MES and SaaS security architecture. Security is the important one, as you know. Yeah, the SaaS platform was implemented with a multi-tenant architecture to enable more secure collection and management of information assets in a cloud environment. Tenants were given unique IDs to access specific modules. This ensures that data and modules operating in an isolated environment so that one tenant's data or actions do not affect another tenant. This ensures that each tenant's information is protected and is better protected against data leaks and unauthorized access. It maintains a consistent level of security across the system and enhances prevention and responses to the security tenants. Multi-tenant architecture also provides for resource sharing and efficiency. Okay, so let's dig into the discussions and challenges issues in this technology. Limitations of on-premise MES is first can be discussed in this topic. Currently, the rapid growth of smart manufacturing environments such as smart factories is making MES even more important than global market for smart factories was valued at $79.41 billion in 2021 and is expected to grow to $191.02 billion by 2030. And this growth emphasized the needs for companies to adapt MES to efficiently manage their production processes and improve productivity. Germany, the United States, and other major manufacturing nations have made significant progress in digital transformation and are actively supporting the deployment of smart factories for small and medium-sized enterprises. However, despite the fact that Korea's manufacturing industry accounts for a higher proportion of GDP than its peers, the country has been slow to smarten its manufacturing sector compared to other advanced manufacturing economies. It is the whole the structures of the nations and our nation's huge problems nowadays. For most small and medium-sized enterprises in Korea, off-the-shelf MES is customized to meet the needs, which is costly and time-consuming. Okay, so after we organize this discussion problem, we can tell to organize the information as a first problem and discussion point is that large initial investment, and second one is time consuming to implement, third one is lack of available resources, fourth one lack of know-how, and choosing a solution and lack of specialized IT department is also a problem and the discussion point. After we implemented the MES and improve it to the subscription MES with the SaaS platform technology, it will be a great solution for the industry and nation's problems. Okay. it was like so, okay. Second issues and discussion point is that issues with the transitioning to subscription-based services. Subscription MES is showing great growth prospects at home and abroad. In the overseas market, it grew at a CAGR of 16.3%, and in the domestic market, it grew at a CAGR of 14.9%. Cloud-based subscription MES-SaaS platforms are a solution to the problems of traditional on-premise MES that virtualize the resources you maintain in-house, providing redundancy and lowering your cost burden by paying only for the capacity you store. Use cases based on SaaS platform include database systems and Microsoft Office software, which is really popular. The current trend towards subscription MES continues. However, there are important technical, operational, and organizational issues that need to be addressed before widespread adoption of the cloud at the SMEs. In addition, to reduce anxiety about sharing and using data when adopting the cloud, organizations need to ensure that the authenticated security keys and passwords are in place to prevent data breaches. Yes, it is concluded with the two discussion points, and we have some expectation to discuss with the popular expertise and great authors in the conferences ahead, with the great opportunity to participation in these conferences. Thank you so much for the listening, and we hope to meet you at another conferences or then another cooperation opportunities. Thank you so much.